Good day. Welcome to the first of two videos on chapter 1.5 about angles and angle measurement. Now, as a remark, we know that angles are everywhere. So, for example, if you play sports and you want to kick a rugby or soccer ball to hit the post, all right, there's a little bit of angle calculation happening, all right? So the question is, in our model of algebraic vectors and straight lines, is it possible to define angles mathematically? All right, and the answer is, of course, yes. All right, so we are going to define angles and angle measurement in our model. All right, now to start, let's think, what is an angle? An angle is something between two rays. All right, so here is the definition. So let ray 1 be the rays originating from point A and passing through point A plus B. And let ray 2 be the ray originating from point A and passing through the point A plus Q. Now, we want P and Q to be non-zero vectors, and P could equal Q, that we don't mind. So, if we do calculate the equation of ray 1 will be all the points of the form A plus TP, where T is greater or equal to 0. Remember, if you're dealing with a ray, the parameter is greater or equal to 0. All right? And you can see, if T is 0, you get point A, and if T is 1, you get point A plus P. Ray 2 is a set of points. It's a set of points of the form A plus TQ, where again, the parameter T is greater or equal to 0. Again, if T is 0, you get point A, and if T is 1, you get the point A plus Q. All right? So both rays originate from the same starting point, which is point A. Now we say the set ray 1 union ray 2 of all points on the two rays is called the angle formed by the two rays. All right, again important, they have the same origin. So the angle formed will be a union of two rays with the same origin. This is the definition in our model. All right, but now the question is, how can we find the angle if we're not given rays? So if we're not given rays, we have to be given something. So typically we will be given 3 points, maybe point A, maybe point B, and maybe point Q. So what you do is, if you want this blue angle as depicted, so what do you do? All right, so you apply the definition. So you see that this lies between two rays. So you, as before, you form the ray starting at point A, passing through point P. This will be your one ray. Maybe call it ray 4. And then you form the other ray starting at point A, passing through point Q, and you can call it ray 4. And so now we can see that this angle is the angle formed between the two rays. All right. So given any angle scenario, you can convert it into a scenario of an angle between two rays. So this is showing that our definition is doing quite well, all right, and the importance of looking at rays. Now, some remarks. So if P is equal to alpha Q, then, and alpha is positive, then the rays are the same, and we want the angle magnitude to be 0. All right, because then the two rays are sitting on top of one another, and so our intuition is we want that angle to be 0. All right, here I've sketched two more angles. So here I have angle alpha and angle beta. So looking at it, you can see that the magnitude of the second angle is more than the magnitude of the first one. So we want to define things so that if we fan our ray, that the angles gets more. All right, so we want to come up with good definitions so that the angle alpha is less than the angle beta. All right, so now think about angles. All right, we want angles, if we measure this in radians, to be from 0 to pi. So the smallest value we want is 0, and the biggest value we want is pi, or we want any value between 0 and pi. Remember, we are measuring angles in radians. So let's think a bit. We want a function whose range is from 0 to pi, all right? And the function that you learned in 114 is the function arccos, all right? So remember, arccos takes a domain, the interval from -1 to 1, and has a range from 0 to pi, all right? These are closed interval. If you've forgotten what the arccos graph looks like, please pause this video and quickly Google the graph of arccos, all right? So you got to know what arccos looks like, all right? Now, we know from the Cauchy-Schwarz inequality that the absolute value of x dot y is less or equal to the norm of x times the norm of y. All right? Now, we know from 114, if the absolute value of p is less or equal to q, that it means that p lies between minus q and q. So applying it to this scenario, it means that the dot product, it lies between minus the product of the norms or the positive product of the norms. All right? And now remember that if x and y are non-zero vectors, then the product of the norms will be positive. And if we divide by a positive number, the inequality doesn't change. So we get that x dot y over the product of the norms is between -1 and 1, which means we can insert that into the arccos, all right? So arccos 2 doesn't exist, but if x and y are non-zero vectors, then this expression is between -1 and 1, which is in the domain of arccos, all right? So all of these recalls is the inspiration for now formally to define the idea of an angle. So if we say we have two rays, so the one ray has equation, x is a plus tp, and the other ray has equation, x is a plus tq, where t is greater or equal to 0. So remember, when you see t greater or equal to 0, you're dealing with rays. Then we say that the angle between the magnitudes is that unique theta in the interval from 0 to pi that satisfies the following equation. Cos theta equals p dot q over the norm of p times the norm of q. Or if you want to, you can say that theta is equal to arc cos p dot q over the norm of p times the norm of q. All right? So some remarks. If p is a scalar multiple of q and that scalar is positive, then you're actually dealing with the same ray. So you're dealing with the same ray. And then we want the angle to be 0. But we know if p and q are scalar multiples of one another, and that scalar is positive, then p dot q over the norm of p times the norm of q becomes 1. And we know that arc cos 1 is equal to 0. All right? So this definition agrees with our human intuition. If p is a scalar multiple of q, and that scalar is negative, then the rays are in opposite direction, and so we want the angle to be pi. And in that case, if you calculate p dot q over the norm of p times the norm of q, then you see that theta becomes arc cos of pi. And arc cos of pi, remember, looking at the arc cos curve, arc cos of -1, and arc cos of -1 evaluates to pi. All right? So our formula agrees that if we have two rays going in the same direction, the angle is 0. Our formula gives that. And if the two rays are in opposite direction, then the angle between the rays is indeed pi. Now, if p and q are not scalar multiples of one another, then the angle will be between 0 and pi. All right? And you can also rewrite that equation in another way. And you can say p dot q is the norm of p times the norm of q times cos theta, where theta is the angle between the two rays. Very important. Theta is in the interval from 0 to pi. So theta is not more than pi, or theta is not less than 0. All right? Very important. So theta is in the interval from 0 to pi. All right? And as you can see from this, you got to know arc cos, and you also got to know your special angles. All right? So if you've forgotten about it, make a quick summary. Put it back into your memory, because you are going to need this, because the exam, you will not have a calculator, so you will need to know the special angles if it pops up. Alrighty, so there's lots of examples in the textbook, so do try examples 1.5.5 and 1.5.6. So do it. And if you get stuck, the answer is there. So keep on doing it until you're happy that you agree with the answers in the textbook. But I'm going to do example 1.5.7. It's an interesting one. So here we have two rays. You can see the equation of the two rays, and you can see they both originate from the same point, which is the origin. All right? So they are rays. Why? Because t is greater or equal to 0, so we know they are rays. We can do a quick rough diagram. So we can say this is ray 1, this is ray 2, and you can see all of the rays start from the origin, which is 0. All right? And we want to find all alpha so that the angle between the two rays is pi over 3. All right? Now I'm going to call this vector P, and I'm going to call this vector Q, so I get to apply my definition. All right? So tell the marker what you're doing. So let P be the 3D vector 1, minus 1, 1. And Q is the vector 2, alpha, 1, 1. And we want the angle between the two rays to be pi over 3. All right? And so we now apply our formula. And the formula goes that P dotted with Q is equal to the norm of P times the norm of Q times cos theta. All right, and now we just fill in. We know that P is the vector 1, minus 1, 1. Q is the vector 2, alpha, 1, 1. That's equal to the norm of the vector 1, minus 1, 1. And that is the norm of vector 2, alpha, 1, 1 times cos pi over 3. All right, now we've got to do some more maths. Now we've got to do the dot product. So it is 1 times 2 alpha plus minus 1 times 1 plus 1 times 1. That's equal to the square root of 1 squared plus minus 1 squared plus 1 squared times the square root of 2 alpha squared plus 1 squared plus 1 squared. Cos pi over 3, do you know it? You should know it. It is a half. All right, so remember I told you, you've got to know your special angles. So here was another place where it popped up. So here we get 2 alpha minus 1 plus 1. So that becomes this 2 alpha. This simplifies to square root of 3. This simplifies to square root 4 alpha squared plus 2 times a half. So I'm first going to take it slow. So I'm going to multiply by 2. So I get 4 alpha is equal to the square root. Multiply in. That becomes 12 alpha squared plus 4. And now I'm going to square, so I get 16 alpha squared is equal to 12 alpha squared plus 4. Make sure that you can do this arithmetic. I made a little mistake here. I hope you've noticed it. 3 times 2, that's meant to be 6. All right, it's always good to double check your answers. All right, so we get 16 alpha squared is 12 alpha squared plus 6. Take this to this side, so we end up getting that 4 alpha squared is equal to 6. So we get alpha squared is equal to 6 over 4, which is 3 over 2. And so we get alpha is equal to plus minus the square root of 3 over 2. But now the question is, do they both work? Do they both work? All right? Now, if you have time, check it. All right? But I am going to be quite clever. All right? I am going to say, let's have a look at equation 1. All right? So, look at 1. We see something cool. We see that 4 alpha is equal to the square root of 12 alpha squared plus 6. And the square root is always greater or equal to 0. All right? So you can ask yourself why? Well, because if you sketch y is equal to the square root of x, the domain of this function is from 0 onwards. And if you draw the graph, sorry, I needed more space. If you draw the graph, it's only points in the first quadrant. So this is the graph of y is equal to the square root of x. And you can see that the range is 0 or positive numbers. So you can see that square root x is greater or equal to 0. So 4 alpha is equal to the square root of something, and that's greater or equal to 0. So alpha must be greater or equal to 0. So when we square, we produce a phony solution. All right? But from the original equation, alpha is not allowed to be negative. All right? So be careful that sometimes when you square equations, you create extra phony solutions. So must verify. So the lesson from this example is must verify. And this is why I'm doing this example. And so only alpha is equal to the square root of 3 over 2 works. And that, ladies and gentlemen, is the answer to this question. I hope you enjoyed this video. Have a good day. Till next time.